Now that we've been introduced to implicit differentiation, let's solve some problems that need implicit differentiation, and we have a little step-by-step process here. The first thing we're going to do is, if we have some implicitly defined equation, is just take the derivative of both sides. And you want to remember that if I have some function of y, that its derivative with respect to x looks like its derivative if it were a function of x, but then you have this additional dy dx on at the end by the chain rule. And then finally what you're going to do is you're going to group those dy dx functions. You're going to do the same thing you've done in algebra over and over and over. You're going to get those terms by themselves and everything else on the other side of the equation. So knowing that, let's get started. And we're going to do one that we kind of understand. So xy equals 1. Now, we could solve this directly for y. We could say y is equal to 1 over x, and that means that y is x to the negative 1. That means y prime is, bring down the negative 1, subtract 1 to the power, so it's negative x to the negative 2. So that's pretty easy and straightforward. But let's do this with implicit differentiation, and maybe it'll seem easier to you, maybe it won't. So this is going to need a product rule. So the first thing I want to do is, again, I want to take the derivative of both sides. So the first thing I note is that's going to be 0. And since this is a product rule, we're going to take the derivative with respect to x of x, keep the second term constant, and now we're going to keep the first term and take the derivative of x with respect to y equals 0. So that's y plus x dy dx equals 0. So then we subtract a y, x dy dx equals negative y, and then we divide by x here, so we get dy dx equals negative y over x. And you might say to yourself, okay, well, why is that different from that? Well, and the reason that that's different is because of this term here. So if I plugged in for y, I would have negative 1 over x, which is negative 1 over x, times 1 over x, which is negative 1 over x squared, which is that term. So that's kind of neat. But what's also neat is that if I had a point on the graph that I was analyzing, I would usually already have it in terms of x and y. So I don't need to worry about getting it to look like this. I just have to plug in that point. So this is just showing you that it's the same idea represented a little more differently. So let's keep rolling. Let's take a look at this term. So let's take the derivative here. So again, remember that we know how to take the derivative of 4x squared. You bring the power down and subtract 1 from the power, it's 8x. And if we were taking the derivative of this with respect to x, let's assume it wasn't a y, but if it was with respect to x, you know that that would be negative 16y. But then by the chain rule, we have that additional dy dx on there. And then that's just 0. So if I subtract 8x from both sides, I get negative 16y dy dx equals negative 8x. And then if I divide both sides by negative 16y, I get dy dx equals x over 2y. So what we find is that those are equivalent. This is, if I solved this thing explicitly for y, which I could do, I'd end up with some sort of plus or minus with a square root, And it would be kind of a nasty derivative to deal with, but what this shows is sort of an easy, straightforward way to do it. Now this one's going to be a little more difficult because we're going to have to use two product rules. So to take the derivative of both sides here, we're going to, so notice that's going to be 0, but here we're going to have to do a product rule. We're going to have to do, alright, first term, first grouping, so derivative of first term, and then leave the first term alone, take the derivative of the second term, and then we're going to have to do the same thing here. Derivative of the first term, leave the second term alone, plus first term, derivative of the second term. Well, there's a lot going on here, but it's not as bad as it looks, because this is a fairly easy, this is a power rule, so that becomes 8xy. And we know that the derivative of y with respect to x is just dy dx. Alright, so if this is y, 7y squared, if it was 7x squared, the derivative would be 14x, but it's y, so it's 14y dy dx times x plus 7y squared, and the derivative of x is just 1, so that all equals 0. Now what we want to do is we want to get all the terms that have dy dx on one side and all the terms that don't on the other. So we're going to do 4x squared dy dx plus 14xy dy dx. So notice I just regrouped that here. And then on the other side, we're going to get negative 8xy minus 7y squared. Now that all the terms that have dy dx are on one side, we can factor that out. And then we can divide this grouping here. And that's a little messy, but it's a step-by-step process that we're going to keep following. And this thing, as ugly as it is, if we have a point on the graph that we're analyzing, we simply have to plug in for x and y and reduce.